Linacs technologies.
Hello and welcome back to Simac Demos, videos where we show you how to use Simac to learn or teach specific linac troubleshooting, maintenance, and operational procedures. This paper proposes a method that can be used to correlate the changes in percent depth dose, or beam energy change, with beam depth dose profile slope, or un-flatness of the cross-plane and in-plane profiles. Today we will use Simac to replicate some results published in a research paper, and show how we can use Simac to compare many different beam generations quickly and easily, in our water tank simulator. To do this experiment, we will change the triode gun grid voltage, to adjust the electron beam energy, and will change the bending magnet current, to match the energy of the accelerated electron beam with the bending magnet pass-through energy. Before we get started, we need to simulate the machine in Flattening Filter free state. Let's turn off the Flattening Filter by going to Treatment Head tab, and checking the FFF flag. We can run a simulation to verify the modification. Everything works as expected, as we see profiles that are not flat anymore. Now let's go to the main Simac tab, and modify the bending magnet current, and gun grid voltage. Starting from 14 amps current, and 160 volts grid voltage. Running the simulation. We can see that the beam energy and bending magnet pass-through energy match. Let's check also the profiles. Everything looks okay. Let's save this machine state, to be able to run a water tank experiment with it. Now let's repeat this process with some other bending magnet current values, up until 18 amps. Now that we have all the machine states that we are interested in saved, let's run water tank experiments on each beam, for cross-plane profiles and depth dose. We start by labeling the experiment, and choosing the machine state. For cross-plane profiles, we need to specify the depth at which the scan is performed. For 6 MV beams, the D max should be at around 1.6 cm depth. Let's run the experiment. Now we can repeat for the other saved machine states. Great, now let's compare the profiles by going to the Compare tab. We can see the flatness values of the profiles correlates with the energy change. This agrees with the results that were discussed in the paper. Here we go. We used the Simac to do an experiment, and replicated the procedure and results proposed in the paper. Also, we just did 6 beam and water tank scans, all from the comfort of our laptop and faster than the time it takes to treat a patient. Thank you for joining this Simac demo. See you at the next one. Don't forget, your always free Linacs account gets your 5 Simac runs per day. Show us how you use Simac at linacs.ca.